So, all right. Uh, I'll just do a quick recap of yesterday because this concept is is something which you may have to understand thoroughly. Okay, so where we started yesterday was talking about such kind of architectures. So the point was like such architectures, you don't have a support which you normally see. So the point which we were driving was that when you don't have a support like this, where from the support is coming? What was the conclusion yesterday? This will fall like this, right? The gravity force will act. This will fall like this, right? So what is helping it? The pillars. Yeah, Sam, you message me privately. You can message to everyone. So the pillars are supporting. So you see what direction will be this support? This pillar is supporting like this from here. Is it not? So that pillar is supporting from here. So that is a tough task to support like this. Actually, if this arch was like this, it would have been much easier to support from here because the point which we mentioned yesterday was this angle is very crucial. If you have the force of gravity falling like this, normally you will give a pillar here to support straight away in the same direction. If you give a support from the angle, and as this angle increases, this you have to apply much more force to support this. So when the shape is like this, you are giving support from here if the shape is like this. So this is closer. That was the point which we were driving yesterday. Same thing in this case too. Feel free to ask if you have doubt, those especially those who are not there yesterday. Okay. Same thing in this case too. So here you are giving support straight from here, which is like the force of gravity appearing like this, and the tension of this support supporting it. So straight in the same direction. Here also the force of gravity is like this. The bridge will fall in the center of mass. But we are not giving a support like this. How are we giving support? Can anybody mark it in this drawing? Where is the support coming from? Yeah, so Ridesh is right because there is a rope like this. But what you have to understand, this rope itself getting support from here actually. So this one, though you will see this support like this, actual support is coming from this rope, and this rope is getting support from this pillar. So this is, yes, this gives some kind of balance and stability, but the actual support is coming from this direction. From here, this is pulling, right? You understand? So actually you need to get your support like this. This is where you want to get your support against the gravity. So if you would have got a support like what this told from here, the straight direction, it would have been a much better support. But actually you are getting it from here. So this angle becomes crucial. So what did we understand? So whatever tension you give here, whatever force you are applying from here, the 100% doesn't come here. Only a portion comes here. And this angle is more, means lesser portion only will come. If the support was from here, if you tie from here, this angle is increased, you will get much lesser force. To the extent that if you are supporting from here, you won't get any force in this direction because this is 90-degree opposite. Right? Now to prove this further, we brought this case of you doing exercise. Right? So which is what we told, which is tougher? What was our conclusion? Which is tougher?
A was tough.
A was tougher. So why was it tougher? What was the conclusion?
It was tougher.
Yeah, why was it?
The center of gravity is not supported.
Center of gravity is not supported. Center of gravity is not supported. Now this leg here, the center of gravity is supported. So instead of this position, let me ask you, if the position of the leg was like this is tougher or this is tougher? Original position is tougher or this new position, inclined position is tougher?
Inclined.
Okay, others? When you do real exercise, when your leg is like this, it is tougher or this is tougher?
Sir, inclined.
Okay. Any other answer? So this is more tougher, you are saying? If you keep like this?
So we are comparing it with B, right?
No. I am asking, this is the original position. What if you fold the leg like this in this position? That is tougher. Further like this. This is tougher. Which of this is tougher?
So the original position is tougher.
Original position is tougher. Any other answer? And why? Why original position is tougher? Why this is tougher? Any idea? You tell me, think first, when this leg is folded like this, it becomes straighter. What is the change happening in the motion in the force side? What will be the change?
Height will increase from the leg and ground. So it will possess more energy, I think.
Gravity is depending on mass. Mass doesn't change.
Center of gravity changes.
Center of gravity will shift, right? Center of gravity, let us assume it is here in this direction. Now this will shift here. Here it will further shift here, right? So if you are actually giving support from your buttocks from here, right? So when you give support from here in this position, your supporting angle is like this. This is the angle. In this position, again, your support is like this. So this angle is reduced. In this position, your support is like this. So this angle is further reduced. So that is why when this leg becomes straight, you don't have much of a pressure. Even if your center of gravity is here, you can support from here. Let us assume your center of gravity is from here. It is here. But you are supporting from here. So this angle is much lesser. When this leg is like this, straight, your center of gravity is here. So this angle is more. If you have doubt, after this class, you can ask Yogananda to explain steps like this for different steps. Normally in the gym, if you go, they will ask you to hold it like this. That is the toughest exercise, just above the floor. Yes, Yogananda, do you agree?
Yes, sir.
Just above the floor, they will ask you to keep. Actually, this is easier. Folded is easier. But suddenly our logic will tell us, no, if this is lifted, it is tougher. No, yeah, it is lifted, it is like this, it's easier actually. So that is one assignment for you after this class. Okay, lay in try this. And don't sleep for 2 hours by telling that Satish sir has given us this assignment, so 2 hours, don't sleep and give me bad night, right? Okay, so now this was where we got on from there, and then from there we came to this specific case, and in this specific case we again told, actually speaking, this person is trying to move the tree, trying to apply force like this to move it, but the force is getting applied in this direction, so there is an angle, so you won't get this full force here. And if this person was here, we told, if he was standing here, what we told, then this angle further increases. So he has to apply more force. Not just that this tree may fall on his head also. Okay, right? So don't think you understand trigonometry and try to do all these circuses. People who have cut the wood, they have a much better idea than you. Okay, you can see from distance and do all the calculations. Now further, if you move on, we told with all this experience, we told that means if you are applying a force like this, either pulling a tree example, or in the case of that cable bridge, if you are applying a force in an angle, you get only a portion of that. In the case of tree, you want the tree to move horizontally, want to come to this side, but then you are pulling it with an angle. So this angle, whatever force you apply, you won't get the full force here. So if you are pulling it in the same direction, you have to apply only less force. Here, this angle, more the angle, you have to apply more force. And I told for you to visualize, consider this like you are putting a light from the top and you see what is the shadow you get. So it is very similar to that. That is what I was telling you yesterday. So you put a light from the top, you get a shadow. So if you apply a force in an angle, let us say some angle, you get only a portion of it here. Also, you get only a portion here in the case of cable bridge. In the support, actually you want the support like a pillar, but you don't get the full F here. You get only a percentage of it here. What is the percentage yesterday we told? What is that percentage you will get here? Yeah, Sam, as Sam mentioned, it is sine. Sam, you are messaging me privately, message to everyone. So that is what we call as with the mathematical parameter sine. So I asked this entire course, I asked you to remember only two things. Everything else we are deriving. Okay, typically in these applications, normally you will be asked to like by heart all this kind of stuff. So one of the purpose is to take you away from by heart. So in this whole stuff, I am asking you to remember only two things. Everything else we are deriving, we are understanding through logic. So one thing is this, understand that if you have force like this, the vertical component of that will be a percentage of it, that is called sine. This is the only one out of two things which I am asking you to remember. So of the F, one portion, the sine value will be less than 1. And this X, when this X is 0, what will happen to sine value we told? When this X is 0, this F falls here. Right? When this X is 0, this F falls in this horizontal axis. So what happens to sine value?
There is 0.
It becomes 0. It is simple common sense. When you look here, when this X is 0, this F falls here. So you don't have any component here. Because if you look at it as a light image, when X reduces, this will fall. That's what I was explaining you yesterday. So when this X reduces, F will be here. So you get a lesser F sin X. When X is further reduced, you get only a smaller portion here. And finally, when X is 0, your sin X is 0. And then similarly, when X increases, the sin X increases. When X further increases, the absolute value of F doesn't change. Sin X further increases. And when X is 90 degree, sin X becomes 1. F and F sin X are same. Then sin X becomes 1. Right? Similarly, another point which we asked this, in that case, this is the second thing, only second thing I asked you to remember. Nothing else you have to remember. So what is that we told here? What is it that you have to remember? What is this portion? This is a ratio of F. What portion is this?
Cos.
So that is what we call as cos. So we told that is the name itself coming by telling this is complement of sine. So I told you to remember two things. Actually, you have to remember only one thing, that this is sine. Then you can tell this is complement of it. Okay? But even if you take it 2, you have to remember only these two things. Right? Further from here, whatever we are going to tell, we are only deriving. So that you don't have to remember anything. Okay? So same way, you tell this is f cos x. So when x is 0, you get the full f here. So cos x is 1. When x is 90, the full f goes here. You don't have any component here. This becomes 0. Right? So this is what we established yesterday. So we stopped here. Now I will explain why that cosine is called complement of sine. Okay. So now you assume the shape, I take this angle as x. Previously I took this angle as x. If I take this angle as x, what is this value?
It's cosine.
Yeah, it is cosine. Who told you? Is it Abel?
Yes.
Yes, you see, that is the logic you to understand. So you understand the concept. Now you tell me, Abel, why you told this is cosine?
Because when x is decreasing, the cosine will increase.
And brilliant. You see, so that is where you understand the concept. You know what is the problem if you by heart? You'll tell cos is this horizontal one. Okay. So if you by heart like that, cos is this horizontal, sine is this vertical, then you are gone. Cos is not horizontal. Cos is if you have any force. See, this is like our previous drawing. We have tilted 90 degree. We have tilted it 90 degree like this anti-clockwise. That's all. So what you have to bother? You have to bother whenever there is any force like this. If it makes an angle like this horizontal of it, the angle which you make the horizontal of it is f cos x. Which means what? When this angle becomes 0, when angle becomes 0, that is cos 0 is 1. That is what you have to understand. So always, whichever direction, so this direction could change. Don't bother. Fundamental principle of this business, whatever we are doing. Okay. So this direction could be like this. Okay. This direction could be like this. And I tell you that this makes an angle x with this. What is, you tell me, assume this is f. What is f cos x? Mark it. This is f. This angle is x. What is f cos x? Yeah. How do you know the point? Which point? Which point?
Because it will be horizontal to x.
You are perfectly right. Avinash is perfectly right. It is horizontal. But in which point? Where will x? See, we know to till this point. I told you, it is like you are putting a light here, light image here. So that is why we are drawing this line. So we know f cos x is from, that is why I put this arrow from here to here. From here till which point?
Till f goes.
Yeah. So how would you put that? Yeah. So how do you draw? So that is what you have to get that. So this should be drawn perpendicular. Yeah, this should be Abel, but it starts from here. This should be drawn perpendicular. See, you see how we have drawn? We have drawn in a way that this is 90 degree. Yes. So where if f is only till here, from here we should draw in a manner that this is 90 degree. So this f cos x is from here to here. Do you all get this? This is very important. Just remember this picture. When we draw, it is like it is like a torch, it is like a light we are putting here. How is light coming? Light is coming perpendicular to this axis. And how is this light coming from here? Perpendicular to this. It is like a torch light I am putting from here, perpendicular to this axis. So here, if I want to see the component of S in here, I have to draw a torch light perpendicular to this. Get it? So if this line, instead of this, if it is here, I will put the line like this. If it is like this, I will put like always perpendicular to that. Do you understand?
Yes.
Everyone?
Yes, sir.
Don't by heart this, okay? Don't by heart this horizontal axis is cos. There is nothing called horizontal, vertical and all those things. Because in space, it is 3D. So it can change in any direction. What it makes is, remember the point what Abel was mentioning. When x is 0, cos 0 is 1. Full 1 will be available. Right? So, as we told, this is f cos x. Well, obviously, what is this then?
Sine.
Natural, right? That is f sin x. What is this? Obviously, this is f cos x. This is f sin x. Naturally. Now, you tell me what is this angle? What is this angle?
90 minus x.
X, is it not? That is what you studied the other day. Don't you remember? Shivananda's 180 minus business and our business, this angle is 90 minus this angle and this angle are same, right? So if this is x, this is 90 minus. Is it not? Or you can also get it by telling this and this plus this is 180, so this is 90. So if this is x, this is 90 minus x. What if you get? Right.
Yes, sir.
Okay. So now let us play some algebra. Okay. So we told f cosine x is this, right? F cosine x is this. What will be f cosine 90 minus x?
It'll be the same as f cosine x. No.
Are you sure?
No, it'll be f sine x.
Exactly. See, you see, the bottom line is f cosine x is this. That is the shadow in this. Wherever, see, so, you know, the easier stuff to remember is out of sine and cos, you try to remember only one. Only one. Okay. So you think it like this. If you have any force or anything, to which axis it is making an angle, that is cosine. Right? Here it is making this x with this. So this is f cos x. Previously, in our previous case, this was making angle x with this. So this is f cosine. If this is A, this is f cos A. If this is C, this is f cos C. If this is D, this is f cos D. Do you get that? Yeah?
Yes.
Yeah, okay. So now, getting back to this business, if this is x, this is 90 minus x. What is f cos 90 minus x?
F sin x.
That is this. So this 90 minus x, you think it is A. Assume this angle is A, called A. So we are asking what is f cos A? That is this. Everyone get it? Those who get it, message yes. If you don't get message, no. I don't have any problem in repeating it. Go home and write this, okay? The concept which you understood, the logic, write it. This is tricky stuff. Okay, I'm assuming you are getting. So we are telling if this f of this cos, this thing is same as this value, but this value we already know, this is f sin x. So this f and f will go, so we get cos 90 minus x is equal to sin x. This is why this is called cosine, complementary of sine. Why is it called complementary? Complementary angle, what is complementary angle? If one angle is x, it is complementary angle is 90 minus x. You have learned that, right? Two angles are complementary, when you add, if you get 90. So this angle is complementary angle of this. He plus he together gets 90, right? So what are we telling? Sine of this is equal to cos of this. Sine of this angle is equal to cos of this complementary angle. So cos, we are telling complementary to sine. So sine of any value, sine of x, any value is equal to complementary sine or cosine of the same value. That is 90 minus of that value. Now you understand why it is called cosine?
Yes.
Yeah. So you tell me what is f sine 90 minus x?
Sir, cos x.
F cos x.
Right? Do you all get this? Because we are telling if this is yes, if this is x, f cos x is this is f sin x. Same way, if this is x, if this is 90 minus x, f sin 90 minus x is this. Right? So that concept you just get any kind of a parameter, if it makes an angle, this is the cosine and the vertical one is the sine. So here, if this is yes, if this is 90 minus x, f sine 90 minus x is this vertical, but that vertical value we already have got, it as f cos x. So you get the ulta of it, sine 90 minus x is cos. That is why they are called complementary. Yeah? All of you get it?
Yes.
Okay.
Yes.
So moving forward, if you get back to the bridge, now you visualize it. This is where the force is being applied. Where is it that actually you want support? You want a support here in this direction or from here. Is it not? You want the support here. And we are telling if there is a force like this, it can have two components, one in this direction, one in this direction. And if this angle is x, what will be the support in this direction? What will be the force? This is the actual force we want. So what is the support in this direction?
90 minus x.
This value of this is 90 minus x. What is this value? If this is some, assume
Sine
this
of
is
x.
F sin
exactly. If this is
F
100
sin x.
Newton, assume this is 100 Newton. How much will be this?
100 sin x.
100 sin x. So that means you don't get 100 here. You get a value less than 100. Right? Is it not? And if this, instead of this height, if it is from here, the sin x value will further reduce. If x is lower, sin x value is lower. Is it not? When x is 90 is when you get the entire f towards this direction. That is sin x becomes 1 when this x is 90. So the farther this f is from the direction in which you want the force, lower will be the force. So if now you think instead of supporting it from here, if you are supporting from here, what will happen?
You'll get like 0 support.
You will get 0. That is the problem of that exercise. Now you remember when that exercise, when you do, when that leg is almost parallel to the floor, you are giving force in this direction, and leg is like this. You want force like this, but you are giving almost like this. Realize? Okay, so that is why this is at a height, and the more the height, you get more force. Okay, right? So here you get f cos x, here you will get f sin x. So this and this are same. This and this are same. Same force. Instead of pulling like this, you are supporting from here. So if you have a bridge like this, actually you need only this much force to support. But in this, you need a stronger pillar. Do you remember the question which I asked? Do you need a stronger pillar in this case, or when you have pillar from here? Now do you know the answer?
Yes.
Which one? Instead of this arrangement, if you build a pillar here, which one needs more force? This or that?
This one.
This one needs more force, because pillar means the 100% of force is given in the direction to fight against gravity. Here you only get a portion of it, f into sin x. That portion is called sin x. Now do you understand why do you learn this sin and cos? Right? And this is coming everywhere, where you make a building, bridge, even in a car. Which direction you apply and where it is to move. Everywhere where you apply the force, in which direction you want the force and in which direction you are applying, that has a huge difference. Even while cutting a tree and felling it, this is coming into picture. Understand? Clear?
Yes, sir.
Okay. So now, if I get back to this business again, I tell this is sin x and this is cos x. You see, this takes the shape of a triangle, right? Like, is it not? This takes shape of a square and a triangle like this, right? Why it is? Because you are, I am visualizing it like a shadow of something. So you are dropping some, putting a drop in 90-degree perpendicular so that you get the value of this. So this will give you a feeling of a triangle. Is it not? This is not an actual triangle, but this gives the direction or the shape of a triangle. And the triangle, that is hypotenuse, this is adjacent, this is opposite. All of you are familiar with these terms. What is hype, op, edge? You know?
Yes, sir.
Yeah, this is called hypotenuse, right? Why this is called adjacent? Why?
Near to angles.
Near to?
Angle X.
Near to the angle, right? If you are keeping an angle here, this is adjacent. If you are keeping an angle here, then this is adjacent. Don't by heart. Adjacent means drawn like this, right? Understand the concept. Adjacent is adjacent to the angle. Opposite means opposite to the angle. If you are taking this angle, then this is opposite and this is adjacent. So in triangle has three parts, right? So now what is it that you know, if in a triangle you have this Pythagoras theorem. Pythagoras, as per Pythagoras theorem, this side square plus this side square is equal to this side square, right? So this equation you are not by hearting. You have, I have asked you to remember actually only one thing, either cos or sine. Whatever is sine, the other side is cos. Either you remember cos or sine, whichever is comfortable to you. I always remember cos. Why I remember cos, I will tell you, because it is the angle made. So if is f, I have remembered this is f cos x. And if this is f cos x, this is f sin x. So actually you have to remember in this whole business only one. But when I studied +2, I was made to remember 35 equations. This is what I'm trying to avoid here. So you have to remember only one. Now you know this, right? If this is a triangle like this, if this is f cos x, and if this is the shape of a triangle, if this is f sin x, you can easily write an equation like this, right? Is it not? So then this is f square sin square x plus f square cos square x is equal to f square. All f square you can remove. So you get sin square x plus cos square x is equal to 1. So this denotes the relationship between sin and cos. So what is sin square x? You take this cos square x to this side. So sin square x is 1 minus cos square x. Or cos square x is 1 minus sin square x. Cos x is root of 1 minus sin square. All comes from here. And this comes from here. You all understand this?
Yes, sir.
Our other friends, ladies and gentlemen.
Sir, why is the x not squaring?
X is squaring. X is squaring actually. This whole portion sin x square. Sin x square. This is a notation they use. X is also squaring. So for example, sin x you assume it is 0.5. This is 0.5 square. 0.5 into 0.5. The notation which they use is like this. It's a style. It's a style. If you write sin x square also like that, same, no problem. It's the same thing. Means no trick is applied here. Okay. If there's a trick, I will tell you. There's no trick. Okay. Ridish, you are messaging me privately. Others all get it? Abel, Navijit, Navneet, Vinayak, Gatha, Sam, all of you get? This equation will come behind you throughout, okay? Because 55% derivation is with this equation. Almost all derivations will start from this equation. That's why I am spending time here in this. Okay, right. So now actually speaking, we will get into another business. So now this picture you are familiar with, right? This picture you have to be familiar with, okay? So go home. No need to go home, you are sitting inside the home only. I'm telling inside the home after the class. Just to make this picture, okay? Assume one force and make the drawing of that cantilever bridge. Try to make the drawing of that tree felling bridge. Mark where is the force coming. Mark in horizontal direction how much you will get. Mark in vertical how much you will get. So make this picture and be very familiar with this picture, okay? That is very important to get the concept. So now you tell me what is the value of cos x. Now we know if this is f, this is f cos x. I understand. So this is 100 Newton, this is 100 into cos x, some value. So this is 100 Newton, this might be 60 or 55. And this is 100 Newton, this might be 40 or something. But if I want to know what is the value of cosine of this, let's assume this is 42 degree. How will I get cos 42? How can I calculate the value? If I know all this value, if I know this is the force, if I know this is the horizontal component, if I know this is the vertical component, from that, how can I get the value of cosine?
1 minus root of 1 minus sin x square.
Yeah, but sine I don't know, na? I know. I know only these three sides. I know this is this value. I know what is f cos x. I have calculated this is 100 Newton. And this is assume 60 Newton, and let us assume whatever is 100 minus 60 square. This Newton is this much, 70 Newton, whatever it is. So I know these three values. From that value, how can I get cos and sine values? Just it is so simple. LP school mathematics. Don't think as if you are trying to. I have asked you to solve a great problem. It's extremely simple. Don't show actions. It's very easy. When I am giving you tough problem, I will tell you it is very tough problem so that you can show some decoration. There is no need of a decoration here. It's very simple. Okay.
So cos x is the same as 1 minus cos 90 minus x.
That is right, but how do we know cos 90 minus x, Abel?
That's
We
better.
don't know that, right? We know only these three sides. We know the value 100 Newton of the force applied. Now I measured the force in this direction. I got some 60 as the value. Now I measured it in this direction. I got some 80 as the value. So from these three values, how will I get cos x or sin x?
So wait, do we know the angle?
I know the angle. Yes, I know the angle. Angle you can measure, right? How do you calculate the value of cos x for a specific angle? So you are trying to solve by thinking it is a complicated problem. It is a very simple problem. If you know f cos x and f sin x, how can you calculate cos x value?
Divided by f.
Yeah, that is this side by this side, right? F cos x by f is cos x. See, this side is f cos x. This side is f. So this side value by this side value, you will get cos x. That's why I was telling you don't show decoration. It's a very simple problem. Okay. Is it not? Now what is f cos x? That is this side. This is adjacent side. So this f cos x is adjacent side, f is hypotenuse. So if you have any triangle, if you, let's assume some 30 degree, 35 degree, you make a triangle with that angle and you measure the value of adjacent side, measure the value of hypotenuse, divide, you will get the cosine value. Yeah? And the sine value, how do you get?
F sin by f.
F sin x by f. So f sin x is the opposite side. So you get opposite by hypotenuse. So now, the unfortunate thing is, normally in school, I don't know how it is now. Normally in schools, cosine and sine will be started from here. I don't know how it is for you. Shivananda told other day their trigonometry started. Did you start from here?
Yes, sir. The ma'am gave just equations to find sine and cos.
Yeah, so did you start from here with the definition that cos is equal to adjacent side by hypotenuse?
Yes.
Yeah, so that is the unfortunate or sad part of it. This is only an after effect. This is only something which you derive from the original concept. This is the unfortunate part is the name of this branch of mathematics is trigonometry. Whereas it is nothing much to do with triangles. Yes, it is to do because the shape is that of a triangle. Because you take it like the drop is 90 degrees, it will take the form of a triangle. So you can apply the principle of a triangle, but this is not something to deal triangles. This is something to deal with angles. So whenever you have a force or any parameter on an angle, how do you calculate the horizontal and vertical component is this whole business about? If you don't understand that, if you think cos x is adjacent side by hypotenuse, it will, so what? Right? It will cos x is adjacent side by hypotenuse. So okay, what I have to do with that? What is my business? Right? So this is only a side business of the main business. This is only something which you derive from here. The actual meaning of sin x is the vertical component of any force. Cosine is the horizontal component where the angle is made. But you can calculate the value like this from this picturization. Do you all get this?
Yes, sir.
I hear only Shivananda and Avinash. Others, you all get this?
Yes, sir.
Abel, you got it?
Yeah.
Okay. So this, don't no need to go and argue in the class or something like that, but understand the concept that this is only a middle point. It is like a story. being started from the side hero. Okay, right. So this is only a derivation out from that. One more thing is there, which we will go, and that is important part. That is our last part today. Now, these gentlemen made this pyramid, right, some 6,000 years back. So obviously, somebody would have come and thought, let us make a pyramid. Somebody would have told, let us make this big. Somebody would have told, let us make this big. Somebody would have told, let us make this big. So they would have marked some area. So probably let us assume if they start to decide pyramid by telling, okay, from here to here, something will make this pyramid. How do they know what will be the height of the pyramid when they finish the job? How do they know how much material you require?
They calculated the area of the.
What all parameter, brilliant. What all parameter you need to calculate the area?
The length of the base and the length of the slanting.
Slant.
Yes.
How do you get the slant before even starting to build this pyramid?
You can use the height and the length from the corner to the center.
Yeah. So how do you get the height?
That's you can decide what height you want to build.
How if you decide any height, how do you ensure in this construction you will get this height?
You'll check like how much you need for each height.
Yeah. You see, you have to understand this is made with bricks like this. So like Abel told, you will decide something is the height you want, and you will adjust the brick when you keep it according to that. That's what you meant, right, Abel?
Yeah.
Yeah. So for example, you will start making not the slant, slant value and height are different. Slant is from here to here, height is from the center to there. So let us assume then you may make one line brick from here to the center like this. And probably you will see what is the height of this, what is the base of this. Then the same trend will continue. That is what you told, right, Abel?
Yeah, it'll be the same ratio.
Yeah, it will be same ratio. You will get it. Are you able to visualize? So you keep one brick. It also depending on brick size, and you keep two brick like this. See, don't think this is slant. This is not the slant. This we are marking from here to the center. From here you get the slant. That is different from the height. Slant and height are different. Slant is from here to here. That is more than the height. So this, if you assume they are putting one line brick from here to the center, after putting some these things, and then if you see, assume this height you can measure, if this is y and this is x, if this is y and this is x, assume this whole pyramid base is b, what would be the height of the pyramid when you complete the construction?
Y into b by x.
Yeah, b by 2, or assume brilliant. Assume b is still half, okay, because assume b is still this point. So how do we get it? Others, how do we get that? See what we do. That is the toffee maths. This is toffee maths. We are telling for x base height is y. Now I want to know for b base. B is assumed this is from here to center. It is b. For b base, how much height? How do you calculate? This is same problem as 8 toffee costs 40 rupees. How much 25 toffee costs? Are you able to appreciate? The question is, for x, this is y height. For b, assume b is still center. What is going to be the height? How do you calculate? Simple toffee maths. No response. You are sitting as if you are solving third degree differential equation. This is UP maths.
No, the height will be b into x by y.
B into x by y, you told before different.
No, y by x.
Okay. Right. How do you get it is the question. Others, do you all get it? What Abel told?
Because the ratio is x
Yeah.
is to y, so it will be base is to height. So
Exactly. I'm telling the root. How did I teach you to approach this problem in Toffee Maths, Avinash?
We need to get the unit value, so we need to get the value of b of x. B of x.
Yeah.
B divided by x. Then multiply it by y.
Yeah, you get the unit value for x base y. For unit base, that is 1. What? For 1 what? For 1 centimeter. Assume x
b
is
by x.
Is it b by? There is no b here.
Yes, sir.
1 by x.
Avinash. See, this is same problem as 8 toffee is 40 rupees. How much is 1 toffee?
40 by 8.
So for x, a base makes y height. How much 1 base makes? Unit base.
Y by x.
Yeah, why there is so much confusion in this humble, simple toffee maths? It is the same simple thing, right? Okay, so now obviously for b base, you multiply with b. This b can be any value. So they make the bricks accordingly and make this height y by. What is this y by x called? What is this figure called y by x for this geometrical shape? What is y by x for it?
the angle, like depends on
Angle is not y by x, right? Yeah.
no.
It is not the angle, right? See, now you are telling here if it is y by x, that ratio will be maintained throughout. That's what you are telling. You are right. So what is this ratio called? What is it? Do you want a clue or phone a friend? Okay. Assume you are climbing in a road. Assume if it is uniform.
Oh, it's the slope.
Yeah. So this is the slope, right, my dear friends, cupcakes. Is it not the slope? Or what is slope? There is slope, English word is something you know it, right? What is slope according to you? The English word slope, what does it mean?
Slope of a
An inclined
mountain.
angle.
Yeah, an inclined plane. Inclined plane is told as having slope. How do you calculate the value of slope? Some inclined plane, you will tell it is steep, right? When something is steep, what is it? What does it mean?
It means like
It covers short distance from ground but has more height.
Y is more, X is less.
no, y by x is more.
Yeah, I'm telling for a given X, this Y is more. That means it is steeper.
Yeah.
Is it not, guys? Is it rocket science? See, if this Y is more for this given height, is it not steeper? If this
So
Y
x is less than y.
same X, yeah, come on. If same X, if this Y is increasing, it is steeper. If this Y is reducing, it is less steeper, right? When this Y is 0, then the road is flat.
Yeah.
Is it not your meaning of slope? That is what my meaning of slope in Thrissur side. I don't know in your side, Oman, Kuwait, Cochin and all, what is slope means to you. So is there any, there is one more name for the slope. Do you know what is that? A mathematical name.
Is it just no hypotenuse?
It's a mathematical name. Actually, two more names. I have to tell both the names and then only finish this. Two more names. Okay, with one more name we will finish today. Anyone? It is called gradient. It's called gradient. Have you heard this word?
No, sir.
I will excuse you for
English word, right?
slope is also English here, Nitish. It is not Latin. Yeah. See, gradient I will excuse you if you don't. If you haven't heard, I am fine with it because. But slope, if you tell, you act as if slope. Where is this coming from? I will not agree. Okay. Gradient I agree. Slope is an everyday word. Okay. And there is one
Sir,
more.
I have a doubt.
Yes.
Sir, another word for slope is gradient means, but gradient meaning is a very inclined plane, right?
No, gradient is same as slope. Gradient
Like,
is y by x. If you tell more higher the gradient means higher the slope. Lower the gradient means lower the slope.
actually,
Yeah?
I have learned it as a very inclined plane.
Yeah, no. That means they will be telling high gradient. There is one more word.
Sir, it is slant height of a cone or some slant height.
Slant. Okay. The more slant means more slope. There is one more word. With that, we'll stop today. Related to trigonometry, what we are studying.
Tangent.
Tangent. Finally, Shivananda is giving me some breather. I was like shell shocked. I was about to get this heart attack when you told stop, you don't understand. Okay. So that is called tangent. What is meant by tangent? The English word called tangent. What does it mean? Have you heard people telling, oh, we were discussing something and this guy went in a tangent? Have you heard that?
Straightway.
No, sir.
Straightway means. See, in English, when we use, oh, that person, he went in a tangent means we were discussing something, he went in a different
Sir,
direction.
like, does a tangent mean like a person who thinks very differently?
Very differently. This is tangent. Tangent to a curve at a point is something which you draw like this. Tangent to a circle, you will tell circle for one point, you can only draw one tangent. Yeah? So this tangent is something. Why now you tell why tangent is called slope? So what we tell, slope of this curve at any point, if you want to find out, draw a tangent and find the slope of the tangent. That is the same as slope of the curve. How do you calculate the slope of this tangent? Slope of this line?
Y by x.
Y by x. Same thing. Like this. Draw. Mark y. Mark x. Tangent is, slope of the point is y by x. Yeah? So that is also called like sine and cos. This is the third element. Tangent or tan.
Tan.
Tan. That is tangent. So this angle, that is depending on this angle. Nah? If this angle is more, what will happen to the tangent? Let us assume this angle is more. What happened to the tangent? Y by x, it increases or decreases?
increases.
It increases, slope increases. If this angle is more means what? Slope is more. Angle further means y is more. Angle further more means what? Y is more. So this tan of this angle is this tangent. And this angle is less means y is less. So this value is less. So from that you get the concept tan of any angle. Assume this angle is theta. Tan of any angle means when angle is less, tan value is less. When angle is more, tan value is more. What will happen to this value when tan 90, when angle is 90?
1.
Is it 1? Is it 1? Shivananda? What happens to y when this is straight?
No,
Y will be the tangent.
will it be infinite slope?
It will be infinite. Very happy I am. That is super.